What about a rational expression in which the numerator and denominator are both polynomials? Well, if we encounter such a rational expression in factored form, things are still pretty easy for us. For example, if we meet this rational expression, well, we see that x squared plus 2 is a common factor, x minus 1 is a common factor, and that's it. Notice that these factors are all prime. We cannot factor them any further, so unless they're identically the same, they have no hope of having anything in common. This rational expression simplifies to just 2x plus 3 over x plus 1 times 2x squared plus 1. So once we have a ratio of polynomials written in factored form, we can treat it just like a ratio of monomials. I'm going to give you one of these to try as well. Again, treating it just like a ratio of monomials. I promise that all of the factors you see are prime. Simplify this ratio of factored polynomials. Pause the video and try this now. Alright, I certainly see 2x plus 3 as a common factor. 4x minus 1 I see as one factor in the denominator, but 2 in the numerator. I'll cancel one of them, leaving me with only 1 in the numerator. And then I have an x over x squared. We can cancel one of those as well, leaving us only x to the first in the denominator. So what do we find? In the numerator we still have a 4x minus 1 times x squared plus 1. In the denominator we have an x times x plus 1 all squared. Notice that x squared plus 1 and x plus 1 all squared, completely different polynomials, right? For example, if we plug in x equals 1 here, this is just 1 plus 1 is 2. If we plug in x equals 1 here, 1 plus 1 is 2, and then we square it to get 4. Completely different polynomials.